Math and Beats. In this video, we are going to look at what is called subsets of real numbers. Here we go. Okay, what is a subset? Well, let's let A and B be sets. Then we say that A is a subset of the set B, or we could also say A is contained in B, but usually we use subset. So A is a subset of B if every element of A is also an element of B. And the notation that we use, this notation right there, A is a subset of B. So it kind of resembles a less than or equal to sign, but it's bigger and it's curvier, that top symbol. And just like for the analogy with the inequality, we could also write this same statement right here. A is a subset of B. So it doesn't matter if you write B or A first, just as long as the subset symbol is pointing in the right direction. So that's what it means to be a subset. That is, if every element in one set is also an element of the other set. Note that if there is some element in the set B which is not in A, then we say that A is a proper subset. Has good manners. We'll see an example of this. But firstly, we say that two sets A and B are equal only if they are subsets of each other. So if everything in A is in B and everything in B is in A, then they must be the same sets. So if that happens, then we say the sets are equal. A equals B. Go figure. Here's an example to get us going. All right, let's let set A be this set right here, and that is the collection of prime numbers so that these prime numbers are less than or equal to 29. Assuming positive, of course. And then set B is a set of numbers that are integers and are between 0 and 30, including the 0, including the 30. So we got these two sets. What are in these sets? Well, A, we're just going to list them out right here. This is the collection of prime numbers that is less than or equal to 29. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29. And then B consists of all the counting numbers, including the 0, all the way up to 30. So 0, 1, 2, 3, 4, blah, 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 so on and so on, 28, 29, 30. One thing real quick to note, this dot, dot, dot right there that we used it up there in this set B for the listings notation. That is referred to as an ellipsis, and it means that a pattern continues on in the same way. So that's why I say, okay, it's 0, 1, 2, 3, the next will be 4, then 5. Instead of counting all the way to 30, you say, oh, dot, 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 just keep doing this all the way to 30, but include those elements in the set B. Okay, so we got set A, we got set B, and since we're talking about subsets, the one thing I want you to notice is that A is indeed a subset of B here, and in particular, A is a proper subset of B. So everything in A is in set B, right? 2 is in B, 3 is in B, 19 is in B. Even though we don't see it, the 19, 17, and so on, they're all located right there when we write that dot, 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 that ellipsis. And of course, there are some elements in B that are not in A. For instance, 28. 28 is in B, right? 28 belongs to B, but 28 does not belong to A. And because A is a subset of B, and there's at least one element that is in B that's not in A, then A is a proper subset of B. So that's a little example with some subsets. One other thing that we want to note is recall this symbol for which we call the empty set. It's like a big circle with a line through it like that. Empty set, of course, is a set that is empty. So it's a set, but there's nothing in it. This is also a subset of B. Why? Because it has nothing in it, and nothing is in B. And in fact, not only is it a subset of B, but it's also a subset of A, because A is a set. Sets always contain the empty set as a subset. That's what's stated right here. Empty set's always a subset of every other set, and including itself. Since, of course, empty set is the empty set. Okay, so there's a little background, some subsets and whatnot. What we really want to talk about is how these subsets deal with real numbers, because in our discussion, at least in a single variable calculus setting, we're going to be dealing with real valued functions. So it's important to understand the different subsets of real numbers. And what are real numbers? The first set is what we call natural numbers. Some of this may be review. Natural numbers, denoted by the symbol here, it's like this fancy looking capital N. That is defined to just be the set of all positive whole numbers. So the counting numbers 1, 2, 3, 4, and so on to infinity. We have the set of integers. That is denoted by this fancy looking uppercase Z symbol. And that is the set of all negative and positive whole numbers, including the number 0. So we could write it out right down here below. Z, this set of integers, you think count down all the way from negative infinity, all the way down to negative 3, negative 2, negative 1. It includes a 0, and then just keep counting, 1, 2, 3, and so on. You should notice that right away, based on what we saw above, that the natural numbers is a subset of the integers. Everything in the set N is also in the set Z. What other sets are there? There's the set of rational numbers. Rational numbers, denoted by the Q here, fancy uppercase Q set. And this is the set of all quote unquote fractions in which the numerator and denominator are both integers, but of course the denominator cannot be 0. So how can we write that out? We'll use listings notation here. It is just the set of all things that look like this, right? A fraction A over B, where both A and B are integers and B is non-zero. So 7 over 5, negative 19 over 4, whatever ones you could think of. And then just another thing to note, this is also the same as saying the set of all terminating and repeating decimals. So you may recall that if you are a rational number, which is a fraction, where numerator and denominator are both integers, denominator non-zero, every number of that form, when expressed as a decimal, is either repeating or terminating. So that's a fact. What if you're not rational? You must be irrational. So there are other numbers called irrational numbers, and we denote them by this symbol here. It'll make a little more sense when we talk about the set of real numbers in a moment. So that is this capital fancy looking R, and then kind of fraction looking symbol, and then the set of rationals. So what that says is this is all the real numbers, as we're going to say, which cannot be expressed as a ratio of two integers. So they can't be expressed as one of these up here. Easy example of that is pi. Pi is irrational because we cannot find a fractional representation of pi, at least in the form that is rational. So it's in that set. Pi is not a rational number. And so you think about rationals and irrationals, well, you combine all of those and you get the set of all the real numbers, which is denoted by this R here. So really this notation for irrationals above is like saying we have the set of reals and we're going to say what what's all the numbers that are not rational. So you combine all of the rationals and irrationals together, and you get the set of real numbers. So pi is real, -1 is real, etc. So many, infinitely many. All right. This diagram right here that I'm about to show you, this is a way to visualize the subsets of R. So we just saw N, Z, and Q. The natural numbers, the integers, and the rational numbers, those are all subsets of the real numbers, right? All fractions are real numbers. All positive and negative whole numbers are real numbers. 0 is a real number. And then, of course, the set of all irrational numbers is also a subset of R. Combine Q and all the irrationals, and all this stuff gives us the set of reals. Notice there's no subset, some sub-box over here underneath the rationals, because there is no subset of those that are real. But over on the left, there's a few different boxes, right? We note that every integer is also equivalent to writing a specific fraction. So you think about what's in Z again, that's the set ... -2, -1, 0, 1, 2, 3, and so on. All of those are positive or negative whole numbers or 0. So every number in here, you know, if you say let A be an element of Z, then we can express A as A over 1. And hence, pick all these different numbers of A, where A is a positive or negative whole number or 0, and it can be expressed as a fraction, so of the form which is rational. Hence, every integer is a rational number. And then we already talked about earlier, every natural number is also an integer, so it's a subset of the integers. And then 0 is lurking around here somewhere, right? So where is 0? 0 should be located in the integers right there, not in the n. N starts at 1. So the collection of real numbers, any number that comes from this realm, we want to go play games with. So all that stuff we just stated is stated right here, right? Natural numbers, subset of the integers. Integers, a subset of the rationals, which also means the naturals are a subset of the rationals, and all of those are subsets of R. And then, of course, the irrationals R, get rid of the Q, that's also a subset of R. Here's one last example. Before we end the video, we're going to be given two numbers below. And we're going to determine which subsets of real numbers the number belongs to. And if a number belongs to more than one subset, then we're going to state all of them using the correct notation. Here's the two numbers, -1 and 2 pi. Well, we know 2 pi is irrational because pi is irrational. So 2 pi belongs to the irrationals. It also belongs to the reals. -1 is an integer. Note that -1 is not a natural number. So since -1 is an integer, -1 is also a rational number, and it's also a real number. So these two numbers, let's just organize it all. -1 is an element of the integers. -1 is an element of the rationals. -1 is an element of the reals. Now we were asked which subsets of reals, but remember, a set is always a subset of itself because it's equal to each other. So -1 also in the reals. And then on the right part B here, 2 pi, like we already wrote, is irrational, and it's also real. So that's it. That's it for the video. Big thing in this video, subsets, and then also how are the real numbers constructed and what type of different subsets are our main ones of focus that that we'll be interested in. And that's it. That's the end of the video. There's more on sets to come. Stay tuned. Later.